Scene script, pod security standards in Kubernetes offer a framework to ensure pods operate under defined security parameters. 3 profiles, baseline, restricted, and privileged, guide the security posture for pods, from the least restrictive to the most. For example, a financial application might use the restricted profile to enforce stringent security controls, minimizing the attack surface. The Pod Security Admission (PSA) controller enforces pod security standards at creation and modification times. It ensures that pods comply with the selected security profiles, effectively preventing the deployment of non-compliant resources. Deploying the PSA controller acts as a gatekeeper, enhancing the security posture by enforcing defined standards. Authentication in Kubernetes is the first step in securing access, distinguishing users and services. Methods include certificates for machine-to-machine communication, tokens for temporary access, and integration with external authentication providers. A practical application is using service accounts with limited scope tokens for automated tasks, ensuring principle of least privilege. Authorization determines what authenticated users can do. Kubernetes uses role-based access control, RBAC, to assign permissions based on roles, tightly controlling access to resources. Implementing RBAC effectively can involve creating roles with specific resource permissions and binding them to users or groups, like granting a monitoring tool read-only access to pod metrics. Secrets in Kubernetes are used to store and manage sensitive information, such as passwords and tokens. Proper management includes encryption at rest, limiting access using RBAC, and avoiding hard-coded secrets in code or container images. For instance, using secrets to inject database credentials into applications at runtime enhances security by keeping sensitive data out of source control. Isolation and segmentation are vital for limiting the impact of a breach. Kubernetes namespaces segregate resources for different environments or teams, while network policies define how groups of pods can communicate with each other and the outside world. Applying network policies to create a zero-trust network model prevents unauthorized access and lateral movement. Audit logging in Kubernetes tracks who did what and when, providing a trail of user and system activity. It's crucial for security analysis and identifying suspicious behavior. Ensuring comprehensive audit policies capture relevant events like changes to workloads or configurations aids in security and compliance efforts. Network policy in Kubernetes specifies how pods communicate with each other and external endpoints. Defining fine-grained network policies restricts traffic to legitimate flows, enhancing security. An example includes isolating front-end and back-end services, allowing only specific pods to communicate with each other, thereby reducing the risk of internal threats.